Hello guys and welcome back to the sessions. Very good evening to all of you, and today we are again back here with Sprint X for your class 10th examinations with some very important and most probable questions for your board examinations. In the previous session we had already dealt with triangles, 7 questions of triangles, and today again we are back here with 7 more questions for triangles chapter. So that will make a total of 14 questions for you guys for triangles chapter, and I guess that would be really sufficient. So with this mindset and with this thought, I am again back in front of you all, giving you 7 more questions for triangles and making your preparation more crisp and more to the point with the boards in mind. So get back to the session. Let's start without wasting much time. Let's start the session and see which 7 questions are in today's box. So let's see the important questions. This is a schedule, needless to say. I guess by this time you would have learned it, or by this time you would have known. So moving on, here goes the first question of today's session. It says that in the given figure, ABCD is a parallelogram and E divides the BC. This E divides BC in the ratio 1:3. So I'll just start solving this question. E divides in the ratio 1:3. So if this is 1, then this will be 3. Now this is 1:3 and AE intersects at F. So AE intersects BD at F. It is given. And we have to show that DF is equal to 4 times BF. DF is equal to 4 times BF. Means we have to show that this is of the ratio 1:4. So how we will show that? Let's see. Very easily I can write it down here. I'm writing here that BE upon CE is equal to 1/3. It is given. BE by CE equal to 1/3. So this implies I can write BE is equal to, if K, then CE will be equal to 3K. I have assumed it, let. Do you understand this? We can say that because once any number is given in the ratio, we can take it as K in form of any variable, 1K and 3K. So 1K and 3K is this. Now if you will be able to see that B is K and C is 3K, so the whole BC, this implies BC would be 4K. And if BC is 4K, then surely AD will be also 4K. So I am writing here, this implies AD. AD is also equal to 4K. So I guess now it's solved, isn't it? Why I am saying that it's solved, I'll just tell you. And for telling you, I'll just use some other color. See here. This angle and this angle is equal. Why? Because it's alternate interior angles, and similarly this angle and this angle will also be equal. Why? Again, alternate interior angles. So both the triangles are similar. If both the triangles are similar, so I'm writing down here that I can write triangle FAD is similar to triangle FAD then FEB, triangle FEB. Now if I have used this, then I'll write, I guess reason is you all must be knowing AA similarity. It's an easy one. So now I can write down that FA divided by FE is equal to AD divided by EB is equal to FD divided by FB, isn't it? So FA divided by FE is equal to AD divided by EB is equal to FD divided by FB. So I guess you know the value of AD and EB and AD. So if I know the value, I'll write here, this implies in place of AD, I guess you all must be knowing it's 4K. So I'm writing 4K divided by, in place of EB I shall write K. This I have written here. And FD upon FB. So FD upon FBF. So I am writing is equal to DF upon BF. So if this is DF upon BF, then K and K will be cancelling each other. It will be 4:1. is equal to df upon bf. Is it clear to you all guys? Is it clear? And see, we have to get this one only. df is equal to 4 times bf. So once we will be doing cross multiplication, df will be equal to 4 times bf, and this is that much easy, isn't it? So I guess you would have understood this question. Show that df is equal to 4 times bf, and apart from that af is equal to 4 times fe. So it's needless to say that here you will be putting the value and you will be getting that ratio also. If I put here 4 upon 4k upon k, then using this af upon fe, I can even get the same value doing the cross multiplication. It will become af is equal to 4 times fe, sorry, 4 times fe, isn't it? I guess I have made my point clear, isn't it? So this is an easy one, not that much tough. Only you need to recognize that how you should solve this. Once you get the whole picture that yes, you should solve like this, you will be able to get the complete answer. समझ में आया होगा? I guess it must be clear to all of you. आसान है क्वेश्चन ज़्यादा tough नहीं है. It's not that much tough. Just you have to put the right steps in the right time. Okay. Now moving on to next question. Assuming that you have understood it. Say for example, if you do not understand any of the question, what I would suggest that after the end of this session, go to this video again and replay it, because it will help you. Because I have seen that many of the students in the comment box, they put that sir ये वाला step समझ नहीं आया, this I did not understand, please explain. तो जो चीजें नहीं समझ आती है, when I give them this comment that you can again revisit the video and replay it, so when they do that, they understand it in a more better way. So I suggest you all also, if you don't understand, then go back to the video. Now moving on to next question. This is our next question, okay? So in the figure, PQR and QST are right angle triangle, okay? It's looking that yes, this is right angle triangle. This is also 90 degree, okay? So prove that QR into QR into QS is equal to QP into QT. I guess similarity must be used because it's a triangle chapter, and this is the only thing with which we can prove any multiplication of the sides. So I guess shall we start with our similarity? So what I will write here in the similarity, I'll just tell you. Angle Q will be common in two triangles, and angle R and angle T is equal. So I will write triangle PQR first is similar to, if I have taken PQR, then I will be taking SQT, triangle SQT. Now how I have taken, because Q equal to Q and R is equal to T. So why? Because R is 90 degree, T is 90 degree, and Q is common in both. So Q, only two angles should be equal. If you are able to get two angles equal, then automatically angle similarity will be applied. Now both of them are equal, so write the ratio. PQ upon SQ is equal to QR upon QT is equal to PR upon ST. So I guess now answer is yours. You will just cross multiply it here. You will cross multiply it here, and you will get the answer. Just do the cross multiplication. You will be getting QR into ST. QR into let me check that what was the QR into QS. They need QR into QS. So QR into QS, sorry, not this one. You have to multiply these two. So let's see. You have to multiply both these two. You multiply this one and you multiply this one. So what you will be getting? PQ into QT is equal to, when this will be multiplied, you will be getting QS, this is QS, and into QR. Now QS into QR is equal to PQ into QT, and this is what we had to prove. I'll show you. QR into QS is equal to QP into QT. QR into QS is equal to QP into QT. So this is what we had to prove, and it was just a very easy question, I would say. It's a only 3 steps question. So in this manner it will be proved. It will be a surely 2 to 3 marks question, predominantly a 3 marks question, or it can be even asked in 2 marks, but yes, it won't be asked in 4 marks question. So I guess I have made my point clear. Now moving back to the next questions. Let's see the next question. And here goes the next one. It says that in triangle ABC from A and B, altitudes AD and BE are drawn. Prove that ADC is similar to BEC. And then it is asked that check whether ADB is similar to AEB or not, and ADB is similar to ADC or not. Okay, let's see whether first try to prove the first question, and thereafter we will move on for the next one. So we have to prove this ADB and BEC. Let's see about that. So in ADC and BEC, ADC, angle D is 90 degree and angle E is also 90 degree because both of them are perpendicular altitudes. Okay, now ADC, so angle C is there, ADC, and in BEC also angle C is there. So if angle C is common in both, I guess you would be able to understand that triangle ADC, I am writing here in triangle ADC and triangle BEC. In triangle ADC and triangle BEC, I guess you would be able to understand that angle D is equal to angle E equals to 90 degree, and thereafter angle C is equal to angle C common. This is common. Now this would be the question in many of the students' mind that, sir, in the previous question we did not prove the similarity of the triangles by writing that this and this angle is equal, and here we are writing. So is it required to write in every question that we need to prove the triangles to be similar, or it's not required in any question? So what I would suggest, see, whenever your objective, means in the question, the objective of the question is that you have to only prove that they are similar, then writing the similarity steps is very important. Otherwise you won't be getting marks. So here the question is itself only this much, that you have to prove both of them as similar. But in the previous question, it was not the objective of the question to prove them similar. Rather the objective was something else. For that objective, it was important to prove both the triangles as similar. So what I did, that when I was writing that both the triangles are similar, then I just wrote down angle similarity without explaining or without proving the whole term. And that you can also do. Say for example, if a 4-marker question is there, and if the question is very long and there are few steps where similarity is required, so you just write down that which triangles are similar without giving the explanation. But here in this question, this is the only question, ADC is similar to BEC, you have to show this. So here you will have to write steps that how they are similar. You will have to prove it. I guess you have understood my point. So here I have written that both the angles are equal. This implies I'll write triangle ADC is similar to triangle BEC, and reason being angle similarity. Angle similarity. Now once angle similarity is given, it's a complete solution. So I guess you would be able to understand that how this question has been proved. Now let us check ADB and AEB, are they similar or not? So ADB, in ADB one angle is angle D, that is 90 degree, and this is the second angle and this is the third angle. Now in AEB this is 90 degree, okay, but another angle is this angle is not equal to this angle, cannot be equal, okay, and if I talk about this angle, this is the third angle. So this angle is also not equal to this angle, or even this angle could have been equal to this, but it is also not equal. What I am trying to tell, that we do not have any proof that in this either angle A is equal to angle A. So ADB first angle is A, this angle, and in AEB first angle is this. So they are not equal. And since if the angles are not equal, we require at least two angles to be equal. So the first angle is not equal, and even the last angle, that B and B, this is also not equal, this and this. So they are also not equal. So since two angles are not equal, so only one angle, equality of only one angle will not give us any similarity. So that is why they are not similar. And similar would be the case here also. First angle A, ADB first angle is this, in ADC second angle is this. So they are equal or not, we do not have any proof about that, or even the question does not say that this is AD is the angle bisector. So we cannot assume from our own that both the angles will be equal. Until and unless question does not specify that these angles are equal, we cannot assume from our own. So I guess you would be able to understand that how these two triangles are not similar. Now once you have understood this question, This question is again an easy one, but yes, all these questions are important questions. So let's move on to our next question. The next question goes like this. Equiangular triangles are drawn on sides of right angle triangle in which perpendicular is double of its base. Means if base is x, then perpendicular will be 2x. Now it is saying show that the area of triangle on the hypotenuse, a triangle has been made on the hypotenuse, is the sum of areas of other two triangles. Now how we will show that? It's again an easy one. I'll just draw a diagram first, so that I can show you. Any diagram of importance for us? I don't think so, because it does not have a triangle. Yes. So anyways, let's solve this on our own. This is the triangle. Okay. Now this is a right angle triangle A, B and C. Now it is said that equiangular triangles are made. Equiangular means all the angles are equal. This means nothing but an equilateral triangle. So if equilateral triangle is made, draw an equilateral triangle here. Draw an equilateral triangle here and draw an equilateral triangle here. So these three triangles have been made. Now it is said that perpendicular is double of its base. So if I have assumed base as x, perpendicular would be 2x. I will write here, let BC is equal to x. We have assumed BC is equal to x. Now guys, are you able to understand that you can apply Pythagoras theorem and you will be getting the value of AC? So I am assuming that you know Pythagoras theorem. So 2x whole square, that is 4x square, and 1x whole square, that is x square. 4x square plus x square is 5x square. So this will be nothing but root 5x AC. Now this let's name this P, Q and R. So if I want to get the area of APB, I am writing here area triangle APB. Do you know this APB is an equilateral triangle, and equilateral triangle has a formula for area, that is root 3 by 4 into side square, and side is 2x. So this will be 2x whole square, that is root 3 by 4 into 4x square. Okay, I'll take this as first equation. Now similarly for BCQ, so I am writing here directly area triangle BCQ is nothing but root 3 by 4 into x square. Why I am writing? Because x is the side for BCQ. Okay, and for ACR I am writing here area triangle ACR is equal to root 3 by 4 into side square. So side is root 5x whole square. Root 5x whole square. If I solve this question, then what I will be getting? I will be getting is root 3 by 4 5x square. Let us assume this third. Now you must be able to see that if I add first and second, root 3 by 4 is common. 4x square plus x square will be equal to 5x square, and this we had to prove. See, I'll show you. Show that area triangle on the hypotenuse is the sum of areas of other two triangles. So means we have to show. So I'll just add both of them. I'll write here add first and second. So if I add first and second, it will be like root 3 by 4 4x square plus root 3 by 4 x square, that is equal to root 3 by 4 5x square. Okay, so hereafter I'll write hence proved. This is the most beautiful statement, isn't it? Hence proved means we are done. Even if in our exams sometimes we do not know the answer, we just do some steps and something, and then in the end we just write hence proved, so that teacher should understand that yes, we have proved it. Anyways, I have seen multiple copies like this, that even if the student is not able to do the whole solution, or say for example if someone is able to do till here and these steps he is not knowing, so he'll write something, and in the end he'll write hence proved. So anyways, this is a very good thing. In fact, when I was also a student, I used to do this. So anyways, this is the whole solution, whole proof, what we had to do for this question. And I guess you would have understood this question, how to solve this question. Now, if you have understood this, we'll move on to our next question. So here goes our next question, and next question is like this. In a right angle triangle, let's see. In a right angle triangle ABC, right angle at A, AD perpendicular is BC. Then we have to prove that AB square plus CD square is equal to BD square plus AC square. Okay. So this is 90 degree and also this is 90 degree. So first of all, let's talk about LHS. So if I talk about LHS, we have two terms, AB square and CD square. Now if I talk about AB square, I'll write the value of AB square. AB square is looking as hypotenuse for this triangle. I am taking triangle ADB. Triangle AD and B. In triangle ADB, I'll write AB square is equal to AD square plus BD square, isn't it? AD square plus BD square using Pythagoras is equal to AD square plus BD square. Okay. Now see, I'm even showing you how to approach these kind of questions. Say for example, if this question comes to you and this is the first thing which you see that you have to prove this. I don't know how to prove this, but very common sense that here LHS is AB square plus CD square. So what is the value of AB square? We'll take out. AB square is equal to AD square plus BD square. This is the most common thing which anyone will say, because seeing that this is a right angle triangle, so Pythagoras should be applied. And similarly for CD square also I will apply Pythagoras. See, I don't know the answer. I am assuming that I am a student like you all. I don't know the answer. So I am doing all the common sense steps which anyone would do. Now, once I have got AB square, then I will be going for the CD square. CD square. So if I go with this CD square, this is also 90 degree. So this will be hypotenuse AC square. So I'll write AC square and AC square minus AD square. Minus AD square. Okay. Now I have got two values and these two values needs to be added. AB square plus CD square. So a common man will do, add both of them. So I'll also, like a common man, I'll also add them. So let's add them. AB square plus CD square. You are able to see that this AD square and this AD square is cancelled, isn't it? So what is remaining? AC square plus BD square. So I'm writing here is equal to AC square plus BD square. And like a common man, I got an answer. AC square plus BD square. So all these questions, it's not that much tough. It becomes tough when I think that it is tough. When I think that no, this is a very massive question or a geometry question, how it is going to be easy. I don't know how to do it. If you will feel that you don't know, surely you won't be knowing, and surely you might be ending up doing some other steps. But always be very natural, be very, means a common sense. What one will do if he will see AB square. AB square is a right angle triangle's hypotenuse. So a common man will do, he will do means applying the Pythagoras theorem. So I guess I am clear with my point. And all these questions, see, let me tell you, all these questions are 3 marker or 4 marker questions. Few questions were there which are 2 marker questions, but all these questions, this is a 3 marker question predominantly. And all these questions I am trying to solve out maximum of the questions in just 3 to 4 steps or max to max 6 steps, not more than that. So that I can tell you how you can also think like this and save your steps, save your time, and hence you can get some extra edge in your examination. So if you are able to understand this, we will move on to next question. And yes, let me tell you, in the previous session, I do remember I got multiple responses from the student that in the last question 9 square I had made a mistake, that I had written 9 square equal to 36. So that was not correct, I know that, but it was just a silly mistake like you guys do. I also do silly mistakes sometimes, you know, mind pressure and all that. I'm also reeling under a lot of pressure here. So 9 square is not 36, it is 81, and that was just a printing error, you can say. So let's move on to the next question. And the next question goes like this. Prove that the ratio of the areas of two similar triangles is equal to the ratio of square of their corresponding sides. Let me tell you, this is a question of NCERT. You all must be knowing it's a kind of theorem. And RS Gopal, Adi Sharma, everywhere it is given. But still I have taken this question. only with one thought, one concept, that it is very important. So don't leave this question at any cost. Okay. So this is the first triangle, and similarly would be the second triangle. So there are two triangles given. Now what you have to do is draw a perpendicular. Say for example A, B, C, and this is D, and this is P, Q, R, and a perpendicular from here is S. Now it is said ratio of areas of two similar triangles. This means first the given step would be here. I am writing given. Given step would be that triangle ABC is similar to triangle PQR. Now if this is similar, I won't write the all steps. I'll just make you understand that how this question will be solved, so that you would be able to write the steps on your own. Now yes, this, if both the triangles are similar, this B angle would be equal to Q angle, isn't it? B angle will be equal to a Q angle because B is equal to Q. Also this angle D will be equal to angle S because it is 90 degree. So I will just write it down from here. I'll write down here that what I'll write? I'll write that triangle, this implies triangle ABD is similar to triangle PQS. ABD is similar to PQS because B is equal to Q and D is equal to S. And I'll just write down here angle. See, it's not required to prove the whole triangle. It's not required, okay? But yes, I'm skipping 2-3 steps here, which I will even tell you. Given, thereafter to prove is very important, and thereafter construction. Construction would be that you have drawn AD perpendicular to BC and PS perpendicular to QR. These steps are very important. So don't leave these steps, otherwise you will lose your marks. Let me tell you, because this is a proof question, so marks counts the steps. In other numerical question, I can say that you will be getting the answer in 3 steps or 4 steps. That is completely fine. But here you can get the steps in just 2 steps. I can prove it in 2 to 3 steps, but you will get no marks. So don't forget to write those steps: given, to prove, construction, thereafter proof. Okay, so write these steps. Wherever it will be possible, I'll be telling you that yes, you can skip this step. Now ABD is similar to PQS. Now once it is similar, you will write AB upon PQ is equal to AD upon PS. Okay, AD upon PS. Yeah, that's fine. Just take this as first equation. Now what you had to prove? You had to prove the ratio of area of similar triangles. So I am writing area triangle ABC upon area triangle. Before this, let me write it down. I am writing here before that. This one. Before this I'll write something. This is first. I'll write also AB by PQ is equal to BC by QR is equal to AC by PR. This is the second step, and this was already given because the triangles are similar, so this will be already happening. I'll use this part and I'll use this part. I'll show you how I'll use this part. So I will write area triangle ABC upon area triangle PQR is equal to half into base. For triangle ABC, I guess you must be remembering base is BC into height is AD. AD is as the altitude, we had made this altitude, half into base into height, divided by half into base of PQR, base is QR into height is PS. Okay, half into base into height. Now everyone tell me, half and half cancelled, BC by QR. I'll write here BC upon QR and AD by PS. So into this is AD by PS. AD by PS. Okay. Now everyone tell me that I can write it down here that from first AD by PS is equal to AB by PQ. So I'll write here AB by PQ, and BC by QR is also equal to AB by PQ. So here also I'll write AB by PQ. So I'll simply write that from first and second. From first and second, I will write that area triangle ABC divided by area triangle PQR is equal to AB upon PQ into AB upon PQ. AB upon PQ and AB upon PQ. And once you have got this AB upon PQ, so surely you will write AB upon PQ whole square. And since AB by PQ, you have already seen that AB by PQ is equal to BC by QR is equal to AC by PR. So you can write there that AB by PQ whole square is also equal to BC by QR whole square, and that is also equal to AC by PR whole square. Now, I guess it's clear, although it's a long question, or because it's not a long question since it is a proof, so it will take some time and surely you need to write all the steps. It could have been gone very short, but yes, steps are important. We are dealing with CBSE, we are not dealing with some international board or state board. Okay, anyways, so I guess you must be clear here. This was the objective, squares of their corresponding sides. We had to prove that ratio of the area of similar triangles is equal to the square of the ratio of their corresponding sides. So we are done with this question, and I guess you would be able to understand this. Now let's move on. For another question, here goes another question. In triangle ABC, X is any point on AC. Okay, it's any point. If Y, Z, U and V are the middle points of AX, CX, AB and BC respectively, then prove that something. First of all, I think that it is a different question. So I'll just draw a diagram for you all first. Let's draw a diagram. See here. First of all, I have made a triangle. Thereafter going, I can name it A, then B and then C. Now here it is said that X is any point on C. So I have just made this point, let's suppose this is X. Now Y is midpoint of AX. Y is midpoint of AX. So I have made a midpoint of AX as Y. Then it is said that Z is midpoint of CX. So the Z is the midpoint. Thereafter U and V are the middle points of AB and BC. So okay, this is B. This is B. U is the midpoint. U is this midpoint. This is midpoint, and V is this midpoint. So U and V are the midpoints of AB and BC. Now what it is said, then you have to prove first of all UI is parallel to VZ. Okay, so for that I will be just doing a construction. That construction is join B to Z, sorry, B to X, join BX. Now once you have joined BX, thereafter join this line UI. Now you tell me that using midpoint theorem very easily, yeah, not even BPT is not required. Why I am telling this is the midpoint, this is the midpoint, isn't it? Midpoint of both the sides. So this is the midpoint. So this line will be, oi, what is happening, man? This line will be parallel to this line, isn't it? Because of midpoint theorem, isn't it? See, because ABX is a triangle and U is midpoint of this side and Y is midpoint of this side. So I'll write down this implies UI is parallel to BX, and I'll write down the reason being midpoint theorem. Okay, midpoint theorem. Now this is midpoint theorem, and similarly I'll similarly write that here we will join this line, and this line will also be the, since it is also the midpoint, Z is also the midpoint and V is also the midpoint. So BCX, here also this will be parallel. So I'll write down here similarly BX is VZ is parallel to BX. VZ is parallel to BX. Assume at first and assume this as second. So I'll write down this employs from first and second. From first and second, what I'll write? That UI Uy is parallel to Vz. Sorry, Uy is parallel to Vz. So Uy is parallel to Vz is proved in the first time. In the first go, in the first question, Uy is parallel to Vz. And second, it is said that prove Uv is parallel to Yz. Uv, this Uv. Okay. So this is also easier. I'll use another color. Uv. Both of them are midpoints. Pay attention. Both of them are midpoints. So surely it will be parallel. Surely it will be parallel to the third side, isn't it? It will be parallel, yeah. Surely it will be parallel. U and V. So I'll write in triangle ABC. I'll write here in triangle ABC. Uy. What it was written? It was written UV. Sorry. UV is parallel to BC, and reason being midpoint theorem. Midpoint theorem. And see, let me tell you that even in examinations, when this question comes, you can just write down this much. UV is parallel to BC. That will be sufficient. You will be getting the answers. So don't think that sir, only in one line how can you write? You have not proved it. But there is no requirement of any proof. You can just write down all these steps. Midpoint theorem is very important. You need to write down the reason behind it. So in 3 lines, so again you have proved such a question. Sorry, in 3 lines you have proved this question. Not in 3 lines. 1, 2, 3 and 4. 4 steps you have proved this question. So in 4 steps again you have proved 2 questions, and surely this will be a 4-marker question. So be assured with this. Now I guess you would have understood this question, that how this question would be solved. And if you have understood this question, let's move on to our next question. And here goes the next question. Okay, sorry, that was all. So again, it was a wonderful journey with you all, because whenever I come to you guys, I automatically get elated that I am doing this much for you guys and you are getting benefited, because whenever I see your comments in that comment box, it gives me a lot of pleasure and a lot of motivation. Since my words are motivation for you, in the same way your comments and your words are motivation for me. Because when I get comment like this, say for example from some previous sessions, Bhumika Verma, she said that sir, you are doing it great, I really got benefited. Some of the students were telling that sir, you are the best. Some of them were telling, I don't remember the name exactly, although I was just going through the comment box. So some of them were saying that sir, you are doing it many things for us, for our board examinations. I'm happy for you and all that things. So these comments really matters a lot, and these comments keep me going on, because see, it takes a lot of motivation to make such videos for you guys and put it out there in YouTube, that too on time, without any delay, every day. And in fact on mathematics, if I talk about, there is always 2 sessions every day. So I have to make all those 2 videos on time and deliver it to you. So it takes motivation, but yes, that motivation comes from your comments and your views or your responses, whatever I got. And it's really awesome and astonishing. So with this motivation, I keep on doing that, and I'll be keep on doing this. And with this promise and determination, I'll be again saying a goodbye to you all. Seeing you again back in just few hours at 8 p.m. Till then, bye-bye and take care. See you back in the sessions at 8 p.m. Till then, bye-bye.